All right, welcome back. I realized in the last video that it might make sense to back up a little bit and talk about alternating series error bounds real quick because that came up in the question we just worked on. So I'm going to look at a particular series, sum n equals 1 to infinity of negative 1 to the n over n. And I'm actually going to add a plus 1 up there. What that's going to give me is 1 would be the first term. That would be plugging n equals 1 into this because let's take a look. We would definitely get a 1 in the bottom. And then this is the alternating piece of it. It would give me negative 1 squared, so it would be positive. So the first term would be 1. Then the next term is going to be negative because it alternates. And then I'm going to have minus 1/2. And then I'm going to have plus 1/3 because it'll alternate. And then the denominator is going to keep, increasing linearly. So minus 1 over 4 plus 1 over 5 minus 1 over 6 plus 1 over 7 minus 1 over 8, etc. It keeps going. This goes on for forever. So this is an alternating series that converges. I'm not going to talk too much about why that converges, but I want you to see that as we move this way, as we're adding more and more terms, the terms get consecutively smaller, and they get closer to 0. So what I'm going to do is graph these, and I want to point out, so S sub infinity would be the infinite sum. S sub 3 would be the sum of the first 3 terms. So for example, that would be 1 minus 1/2 plus 1/3. So what I'm going to do is create a little graph that looks like this. I'm going to put 1 up here and 0.5 there. And then I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Like that. Now, what I'm going to do is, this would be the n value, and I'm going to graph S sub n. So, for example, S sub 1 would be just the first term, because I only have one term. So I'll graph these in red. That would give us a value right there, because the S sub n for n equals 1 is going to be 1. What is S sub n for n equals 2 going to be? Well, it's going to be the first 2 terms. So that's going to be 0.5. And then what's going to happen is we're going to jump up. But our jump up, because the terms are getting smaller in absolute value and they're getting closer to 0, the jump up here is going to be less than the jump down. And then that would be the plus 1/3. And then minus 1/4 might bring us down to there. Plus 1/5 would bring us to there. Minus 1/6. Plus 1/7, minus 1/8. What I want you to see is that the further we go to the right, the smaller the jumps are. So we're kind of honing in on this infinite sum. And that's kind of the idea of what an alternating series error bound is. So imagine I were to draw that horizontal line here and say that was the value of S sub infinity. If I could somehow go out infinitely long or infinitely far with this sum, I would get to a height of that purple line. Now, my question for you to think about right now is how accurate is S sub 6? So, and what I mean by how accurate is how close is S sub 6, which would be this one, to S sub infinity? Well, what I want you to see is that when I go from S sub 6 to S sub 7, I jump over the value of the infinite sum. So, what I want you to see, and I'll write it, that the absolute value of A sub 7, because that's what this jump up would be, A sub 7, since A sub 7 jumps over the purple S sub infinity line, then the absolute value of A sub 7, whether I'm jumping up or jumping down, actually puts a ceiling on the error. And the error would be this length right here. So that from the red value of S sub 6 up to that purple line. Now, that's why we call it alternating series error bound, is because the value of A sub 7 becomes a bound, a highest value of that the error could be for S sub 6. So, let's take a look at a series. Sigma n equals 1 to infinity of 1 over n squared times negative 1 to the n. And here's the question that I'm going to ask you. How close is S sub 4, the fourth sum? We call that the fourth partial sum. Sometimes that language will come up. It's the fourth partial sum. It's part of the way towards S sub infinity, and it's the fourth one. So how close is S sub 4 to S sub infinity? Or what's the best estimate that we can come up with that? So what we can do is, if you look up here, I'll remind you, S sub 6, its error its maximum error was the value of the next term, A sub 7. So if I want to know how close is S sub 4 to S sub infinity for this series right here, well, I can look at the term that would come next. What term would that be? It would be A sub 5. I could even write the absolute value of A sub 5. A sub 5 itself is going to be, I'm going to get a negative 1 over 25. So that tells me that S sub 4 is within at a max of, I don't like that language, at most absolute value of A sub 5, which is 1 over 25, if I take its absolute value, which gives me a decimal of 0.04. So I know that if I were to if I was looking for S sub infinity, and I were to add up the first four terms, that they would be within 0.04 of that first four terms would be within 0.04 of the infinite sum. All right, so let me ask you another question. So, based on alternating series error bound, when is S sub n the nth sum within 0.01 of S sub infinity? Well, let's think about it. We want to know when it's within that 0.01, so when would the error be that? What we can do is take the non-alternating piece, which would be 1 over n squared, and we can set that equal to 0.01. Now, sometimes it's a little bit more work to figure these out, and we can punch them into calculators. But what I can do is write 0.01, 1 over n squared equals, that's the same as 1 over 100. A variety of ways we get there. And then we can, flip and square root, and you should see that n is equal to 10. You could also plug some things into the calculator until we get 0.01. But if n equals 10, that means the 10th would jump over that amount, right? So that means that the value before that, so A sub 10 is the value that would give us that error bound. So that means that the sum of all the terms up until that, which would be S sub 9, is within, that's within 0.01 of S sub infinity. So hopefully that gives you a good idea or a good understanding of what alternating series error bound is. You always look at the next term. If you're really understanding what's going on here, you probably understand why the test for alternating series works. If the limit of the non-alternating piece is 0, and if it's constantly decreasing, then we get something that centers in on something like this S sub infinity right here. So, yeah, there'll be more videos. See you. Thanks.